All right, sixth grade, back on track here. Our objective for today, I know this sounds so exciting, we're going to talk about fractions. Before that, does everyone have their calculator? Yeah. Okay, good. We are going to go over GCF warm-up, and then the second warm-up dealt a little bit with the lesson we're going to do today. And then I just want to go over your homework, make sure you guys are okay, and then finish up a word problem, and then get into today's lesson, okay? All right, so let's, just like we always do, I just want you guys to give me the answer for 1 through 6 on the first warm-up. This was in your homework packet. Alyssa, number 1. Good, 8n squared. Matt, number 2. The first one. Yep. So that would be 6xy squared. Remember, GCF, you have to multiply all of them together, okay? You're thinking of 3 times 2, Adam, is 6. Okay, so Matt, this is not prime factorization, it's GCF. Emma M, number 3. Good. Doug, number 4. No, maybe you just couldn't read my addition there. That was a b to the 3rd and then x. No, number 4 was just hard to read. It should have been b to the 3rd and then x. Emma H? Good. 4b cubed x. That one, that was my fault for trying to write in letters. I will not do that on the test. So b was cubed and then it was x. Yeah. You thought it was the other way around, don't worry about it. It is. I hoped it would have made sense, but maybe it looks messy to some people. Okay, Annalise, number 5. Yes. Yep. Yes. Order doesn't matter. Sean, number 6. Good job. Okay, before I go to the next warm-up, what problems do you need to go over to go back to? Matt? That's right. That's what Annalise just asked. The order doesn't matter. Hopefully you guys all remember from yesterday, and I know I probably said that quickly, but the order of the variables does not matter, and it will never matter. When you learn polynomials in algebra, then the order is going to matter. Emma? Do not do that. You're thinking of prime factorization. For greatest common factor, you need to actually find the greatest common factor, so you have to multiply everything together. Okay, Adam? 9? 9 doesn't go into 20 or 80. Adam? Were you looking at a different number 6? Okay. Okay, Adam, and you were helping Briar, and now I'm a little scared. I'm just kidding. I'm just kidding. You know that, right? Just joking with you. Okay. All right. Adam, let's do this. I know I can joke with you because you always do pretty well. Okay, 20 and 80. What did you break these down? Did you make factor trees? Okay. There's not even a 9 in it. All right, 80. Sorry, I just have to keep joking with you here. Shh, Adam. Sorry. What did you change 80 to? And then would you change 42? Okay, so circle what they have in common, right? So there's 2 2s. There's a 5. Okay, but how'd you get 9? All right. Adam, are you okay? Okay. Briar, are you okay on the monomials now? Are you sure? All right. Adam, good? We cleared this? Okay, Mary. That's fine. That's what I do on the easier ones, so I'm okay with that. Annalise? Okay, that was not either of those. That was 6. Right. But they have to be prime. Yep. Anyone else on that warm-up? Jeremy, you okay? Okay. All right, next warm-up. Then we'll go over homework. Okay, this warm-up, at least I think, was a little bit easier. Dealt a little more with today's lesson, which won't take very long. Alyssa, number 1. Good. 2/4 and 1/2. Oops, that would help if I could write it correctly. Okay, number 2, Sean. Perfect. Number 3, Emma H. Awesome. Number 4, Charles. Good. RP. Charles, tell us again what that means. Yep. What does it mean? Good. The only thing they haven't. Yes, they are. Yeah, that's not. They're not. They don't always have to both be relatively prime. They don't always both have to be prime for them to be right. For them to be relatively prime. Now, of course, in ones like this, yeah, that's going to happen because they're both prime. Okay, number 5, Justin. Good. 15. Annalise, number 6. Good. Sean, number 7. Awesome. You guys did great. Wow. Annalise. Nope. That's what relatively prime means. You can. But relatively prime means that the GCF is 1. Charles. Okay. You're thinking of prime factorization. GCF, you need to mush it all back together. So if you're finding the greatest common factor, it's a factor. So you have to multiply everything back together. You okay? Okay. Anyone else? Questions on the warm-up? Mary? Yes, you may. Anyone else on the warm-up? Okay, let's go over homework answers. And then we're going to go to a word problem. Come on, smartboard. All right. 4.2. Sorry, you guys I know you keep flipping around in your packets here. Okay. Number 2, Donatus. Good. Zach, number 4. Good. Relatively prime. I put a 1 and then I put relatively prime. Either one is fine. Briar, number 6. We're on 4.2, not 4.1. Say that again? No. 3 does not go into 49. You're now thinking about it, what Adam's thinking about. Adam, number 6. Okay, you are right. Good. Number 8, Annalise. Good. 13. I don't know why I did this, but I put in parentheses, not relatively prime. You don't have to do that. You don't have to do that. I don't know. I'm going to erase that. I had that one. For some reason, this was up there from last year, and I think they told me you have to put one or the other. I said, you don't. You don't have to do that. Matt, number 10. Good. Number 12, Doug. Good. 1. So relatively prime. Alyssa, 14. Good. Okay, 16. Emma H. Yep. 18. Donatus. Okay, why don't you sound excited about that? You're so excited. It's 5A. Jeremy, 20. Good. Relatively prime. Emma M, 22. Good. 4Y. Adam, 24. Good. 4ABC. Mary, 26. All right. Mary. Nope. Sean? Nope. Justin? Good. That's a tough one. I'll go over it. Okay, and then who wants to answer the word problem for us? Annalise? Awesome. Wow. Man, we should learn this all year. You guys are doing really well with this. All right. Questions, Matt? Yes. Okay. 6th grade. Annalise, question. Number 2. Did you forget about the 2? Yeah, you probably just, I was just going to say that. You probably forgot to just multiply the 7 times 2. Just, if you, Annalise, carefully circle all the prime numbers that they have in common, you should be okay. Okay. All right. You probably just went too fast then. Sean? Okay. Okay, 26. I like this problem. Okay, we have 12 RST, 42 R to the second, S to the third, T to the second, and RT to the fifth. All right, so Sean, what did you change your 12 to? All right, what did you change 42 to? Yep. You asked about this, didn't you? Okay. I just, in my head, making sure that, okay, and then RR, uh-oh. Okay, and then Sean, the last one, there's not much to do here. R, and then 1, 2, 3, 4, 5. Okay. Circle what they have in common. So what do you want to, let me get my highlighter. What do you want to start with? Do you? Yeah, correct. So you're good then? Well, that was easy. That's all they have in common, R and T. Anyone else on this one while we're on it? Okay, Emma M. You were doing 2 to the second? I wouldn't mark it wrong, but remember, greatest common factors when we multiply all of them. You're thinking of prime factorization, which is in lesson 4.1. It's kind of like if when we were doing inequalities and equations, if you were to change the inequality to an equal sign, that's a big no. I mean, not on the scale, similar. So make sure you multiply them because you are finding the GCF, not the prime factorization. Jeremy. Sure. Sure. Annalise? Go ahead. Correct. Yep. Doug? No, it's 35 a to the 4th. Okay. Yeah. Yep. Anyone else? All right, thumbs up, thumbs down, thumbs down on GCF. Very good job. All right, let's go back to our notes one more time. And I need you guys and girls to flip to page 6. So back to your notes. I want to finish up the GCF word problem that I did not get a chance to do yesterday. And then we're going to go back onto fractions. So open up your notes to page 6. And the word problem is very similar to the one you did in your homework, which you guys and girls did very well on. Mary, you okay? Okay. So we should be okay setting this up. Okay, does anyone feel like reading this for us today? Okay, Briar, nice and loud. Oh. It just said the title should be volunteers. So start reading with a high school. Go ahead. Thank you. Awesome. Okay, let's start with, Doug, you need to raise your hand, okay? Writing down the numbers of each that Briar told us, and then we're going to talk about how we need to approach this. So Briar told us there are 27 freshmen, 18 sophomores, 36 juniors, and 45 seniors. Question is, what is the greatest number of groups that can be formed if each group is to have the same number of each type of student? So the first thing we need to do is figure that out, okay? And then we're going to figure out how many are in each group. So first, what's the greatest number of groups that can be formed? How do we find the greatest number of groups that can be formed with the information that we're given? Alyssa? Good, find the GCF. How convenient, huh? This is in the lesson titled GCF. All right, so let's do this. What do we want to break 27 down into? Emma H. Good, 9 and 3. Sean, what do we want to break 18 into? Good. Annalise, what do you want to break 36 into? Zach, what do you want to change 45 to? Am I going too fast? Okay. If I do, tell me. Sometimes my ninth graders tell me I'm going too fast. Okay. So we have our factor trees. We're ready to go. What can we circle? What's one thing we can circle or highlight? Justin. Okay. 2 3s in all of them. Let's see. Good. Is there anything else? What? Get him. What else? He scared me. What else? Is that it? Okay. So we're not done yet, but the GCF is 9. Who can explain what that means? What does that mean, Briar? Okay, but in regards to the problem, you're right. What does it mean? Go ahead. Good. So it's the greatest number of groups that can be formed. So make sure you write that next to it. Annalise? We're not done. We're not done. We're not done. Hold on. We're in the middle of it. Okay? So the second part says how many freshmen, sophomores, juniors, and seniors will be in each group. So we now need to find the number in each group. Okay, so underneath that, go ahead and just put number in each group. If the GCF is 9, which means that's the number of groups that can be formed, how do we find how many of each type of student are in each group? Charles. Actually, that's interesting. You could do that, but not add them. Yeah, interesting. I would not have done it that way. Does anyone know the way I'm thinking of? Maybe this is the harder way. I just don't think of that. Justin? Yeah, divide each group by 9. It's the same thing Charles said. So let's do that. The freshmen, and I'm going to move this down a little bit. So we have freshmore, sophomore, juniors, freshman, sophomore. Did I say freshmore? Sorry. Freshman, sophomore, junior, senior. Sorry, I'm trying to say it too fast. All right, so how many, hold on, you're probably right. I wasn't thinking of that method. Let me go through it by dividing first, then we'll check your method. So freshmen, if there were 27 originally, and we know there can be 9 groups, how many freshmen are in each group? Briar, how did you get that? Good, 27 by 9. Okay, sophomores, there were 18. Matt, how many sophomores are in each group? Good, how did you get that? Good. 18 divided by 9. Juniors, there were 36. Briar, how many juniors are in each group? Good. 9 divided by 36 is 4. Seniors, Emma M. Good. So 5 seniors in each group. Okay. Let me go back to Charles. Yeah. Yeah, it's not a good example, but Charles, you are right, but it's just not a good example because the numbers weren't big enough. But you're correct. That's what you would do. He said to add all the other ones that are left over. Yeah. So that is interesting. Yeah, like look at whatever's left over. So we did 27 divided by 9 is 3. 18 divided by 9 is 2. 36 divided by 9 is 4. You're left with 2 plus 2 is 4. 45 divided by 9 is 5. You're left with 5. And now, this one's easy enough because the numbers are small enough. Annalise? No, because the first question is, what is the greatest number of groups that can be formed? So that they have the same number of each type of student. So no, the first thing that we answered by finding the GCF is the number of groups we can have. Well, that's what we just did down here. We divided however many freshmen there were by the GCF. Okay, so that means there could be 3 freshmen in each of the 9 groups. 3 times 9 is 27. Okay? Anyone else? Not bad. Zach, you okay? You sure? Am I making your brain hurt? Are you? Okay. Thumbs up, thumbs down, thumbs down on that word problem. Some of you guys, I can't read your expressions. Jeremy. Okay. Let's go then in our notes to fractions. And we'll see how far we get. This lesson's pretty easy, though. Okay. So equivalent fractions. Donatus, when you think of the word equivalent fractions, what do you think of? The same fraction. Oh, you're so excited. Briar, what else do you think of? Good. Fractions that equal other fractions. Justin? Good. The simplified form of the fraction. This whole chart up here, it's kind of hard to see, but these are all examples of equivalent fractions. There's a lot of them up here. Okay? We need to start off with a couple definitions, and then we're going to use our calculator. I'm going to show you how to do these by hand and on the calculator. Okay? So equivalent fractions, 2 fractions that represent the same number. Just like equivalent equations, we're on page 9 in the notes. Just like equivalent equations, equivalent inequalities, which would have the same answer, equivalent fractions are 2 fractions that represent the same number. Thanks for that. So if I said 3/9, what's an equivalent fraction of 3/9? Briar? Good. How did you get that? How did you get that? Just like the problem we did. What's another equivalent fraction? Charles? Yep. Oh, jeez. All right. What's another one? Alyssa? Good. That's the one I was thinking of. Thank you. That would be the most basic one, right? But not in this class. Mary? Good job. All right. We're going to stop there. All right. Simplest form. When the denominator and numerator are relatively prime. Jeremy. Simplest form, when the denominator and numerator are relatively prime. That means they don't have anything in common besides 1. Okay, so relatively prime. And this is where I'm going to introduce some of the calculator concepts to you. Just because when you get into some larger fractions, makes it easier. I was helping someone after school yesterday prepare for SATs, and there were some problems in the SATs that said, put the fraction in simplest form, if you guys can believe it or not. And so she forgot how to do all of it, so I had her use her calculator, and it made much more sense to her because she has not done it in a while. So just keep in mind, you'll see a lot of these basic math skills on your SATs when you take them junior year. Kind of interesting. Hold on, Adam. I'm getting to that. Sean, question? No, go ahead. No, that's not weird at all. I think about a lot of things in a math way, too. Scott, Doug? I didn't know you were homeschooled last year. Were you homeschooled all the way up until this year? Oh. Why? Okay, I didn't know that. Huh. No, hold on. Okay, hold on. Just keep it on there. All right, I'm almost to that part. Okay, equivalent fractions. Okay, next part of the notes. To write equivalent fractions, you need to multiply or divide the numerator and the denominator by the same non-zero number, which you guys, by yelling out all those equivalent fractions, you basically did that. So, Charles, you're with me, right? Okay. To write equivalent fractions, you multiply or divide the numerator and denominator by the same non-zero number. Oh, cool. Oh, I like that. Donatus, are you hot with your jacket on? Are you hot with your jacket on? Okay. Okay, so an example using algebra. Of course, the book likes to give us an example with numbers and with letters. So for all numbers A, B, and C, where B and C are not equal to 0, and I'll write the rest of it in a second. Remember, the equal sign with a line through it means does not equals. If we have A over B, the book tells us A times C over B times C is equivalent to A over B because we're multiplying it by the same non-zero number. Just like if we said A over B is equal to A divided by C, B divided by C. If you multiply or divide by the same non-zero number, they are equivalent fractions. Charles? Yep. Annalise? B and C cannot be 0. Okay. I said that. It just. What, Charles? Right. But you guys just haven't understood yet or haven't learned yet that when you graph, you cannot have 0 in the denominator because it's an undefined function. We're getting to that. Okay. You guys always ask me. We're getting to that. Okay. So an example with numbers. 1/3. If we make an equivalent fraction of 1/3, let's say we take 1 times 2 and 3 times 2. So 2/6 would be an equivalent fraction of 1/3. I multiplied both the top and bottom by 2. Let's say we take 5 over 25 and we divide each of them by 5. 1/5 is the equivalent fraction. So all the definition says is if you multiply or divide the numerator and denominator by the same number, you have an equivalent fraction. If your hand's up, is this a question about this? Okay, if it's kind of, put your hand down. Charles? I'll come back to you. No, that's not acceptable. What? Right. Okay, yeah. You could do that. Adam. Yep. That's chapter 5. Annalise? We're getting there. Hold on. Hold that thought. Jeremy? Okay, I said that 3 times. Does not equal 0. It's an equal sign with a line through it. Remember, it means does not equals. Okay? Okay, so let's do some examples. It says write two fractions that are equivalent to the given fraction. What's one thing we could do to letter A to make it equivalent? Like, could we divide or multiply? Sean? Okay, so if you divide each of them by 6, Sean, what do we end up with? Good. What's one other option we have to this one? Adam? Okay, so if you multiply by 17, what do you get in the numerator and the denominator? Adam! No, that's not right. Are you using your calculator or mental math? Okay, use your calculator for the bottom part because we got to get moving. Yeah. Is he right? Hold on, I'm just trying to do it. Okay, I'm just trying to do it mentally real quick. Okay, yes. All right. Okay, let me show you with your calculator for letter A. So everyone take your calculator. Okay, I want you to type in 6 divided by 18. If you're not staying with me, you have no clue what we're doing. So type in 6 divided by 18. Donatus, where's your calculator? What does it say on the board? Jeremy, you too. Okay, 6 divided by 18. Hit enter. Hit enter. Hit math, which is right here. Hit math. Enter, enter. Good. It simplifies it for you. Annalise? No, the original. The original. You always go back to the original. Sean. Yes. Isn't that kind of neat? Okay, let's do letter B. Let's do one more of these. Okay, letter B. We need two equivalent fractions. So if we divide each of these by 7, Justin, what's the equivalent fraction? Good, 1/2. If we multiply each of them by 2, you always go back to the original problem. If you multiply each of them by 2, Sean, what do we get? Good, 14/28. So that's how you write equivalent fractions. Pretty easy, right? Okay, let's go to example 2. Okay, example 2. Here's where else you could use your calculator. You need to write the fractions in simplest form. So let me ask you this first. For letter A, what is the GCF of both of those numbers? What's the GCF of 8 and 36? Annalise? Good. Since the GCF is 4, to write this in simplest form, you divide each of them by 4. So either by using your calculator and typing in 8 divided by 36, enter, math, enter, enter, or mental math, Sean, what's the simplest form? Good. 2/9. Good. It's the same thing. That's all right. Okay, letter B. What is the GCF of both of those numbers, Emma H? Good, 3. So Emma H, what is that in simplest form? Good. Any questions on that? Okay, let me show you monomials. Flip over to example 3. Okay, no, these are fun. Okay, so we have 14 over 35. Let's start with that first. 14 over 35 simplified is what? You can raise their hand and tell us. 14 over 35. Zach? Two what? I just didn't hear you. 2/5? Okay. Okay, so let's just do, so 14 over 35, 7 goes into each of them. Now the variables, let's write them out. There's 2 x's in the top and there's 1 y. In the bottom, there's 3 x's. What can we cancel? Adam, what can we cancel? Everyone agree with that? Okay, so the simplified answer is 2y over 5x. Annalise. Y is 3 divided by 3, 1. You know what I mean? Same thing as x divided by x is 1. X divided by x is 1. They cancel because you're dividing them. Y divided by x you can't do because we don't know what they are. Anyone else have questions on those? All right, I want you to try the closing on your own. I'll give you a couple minutes and then we're done. Try the closing on your own. You tell me, what's n divided by n? Yep. They are. They're above. This is on the bottom. These are on the top. Yeah. No. Close though. Which one? Yep. Okay, another minute. Keep going on this one. You can simplify further. You can simplify further. You could simplify further. Okay. Letter A. Doug, what did you get? Okay. Letter B, Jeremy. Good. Letter C, Zach. Did you fix C? Over? 1 what? Nope. So look, Zach, we have, so it's really 13 over 1. There's an S and a T at the top, 2 S's and a T on the bottom. What can you cross off? So what are you left with on the bottom? Yeah. Did you just forget about that? Okay. Questions on any of those? Justin? Could you have 13S? No. Think about it. Is 4 divided by 2 the same thing as 4 times 2? No, it's completely different. You can't move something from the denominator and put it in the numerator just because. So if it's on the bottom, you have to leave it on the bottom. Does that make sense? Okay. Sean? No. I mean, you can enter variables, but the calculator stores them as something else. So in Algebra 1, you'll learn about that. If we have time, I'll teach it to you. But the calculator won't do this for you. Sorry. Annalise? You don't have to put the 1 there, but you can. Yep. Jeremy? I'd rather you write it. I want you to write it like this. Zach, are you okay with the mistake you made on that one? Okay. Anyone else? Okay, homework. Practice 4.3. So open up your homework packet to 4.3. Okay, you're going to do all 1 to 29. You may take your calculators if you need to. You should be able to fit it on here. Show your work if you need to. This shouldn't take very long. What do you guys think of this compared to GCF? Okay. Okay. All right. So that's it. 1 to 29.